Hello everybody, today I'm going to be recording a video and it's going to be on Bernoulli's equation. Bernoulli's equation is a topic in Fluids, Unit 1 of AP Physics 2. It is not on the SAT Physics exam, but if you're taking AP Physics 2, it is particularly useful. So, I'm going to get into it right here. So, Bernoulli's equation, what it tells you, it's a pretty long and daunting equation. When I first saw it, I was honestly pretty intimidated by it. But if you look a little closer, then you'll find out that it's actually not that intimidating. So I'm going to write it down in green. So we got P1, and this is going to be the pressure. We're going to have 1/2 rho, this is rho V squared, and we're going to do V1 plus rho G H1, and this is all going to be equal to, since it's an equation, it has to be equal to something, P2, this is going to be the pressure, 1/2 rho, that's supposed to be rho V2 squared plus rho GH2. And so that's Bernoulli's equation. So now we're going to try to use it in the context of this problem. We're not actually going to solve for anything, but I'm going to show you one common application, not the college application, common usage of Bernoulli's equation that you might actually see if you're asked to ever solve. So we have a little, actually a very big tub of water here, and right down here, let me mark it with my rainbow pen. Right here, we have a little leak, and water comes out of it. So I want to try to find out the velocity at which this is coming out. And this is a very, very large thing. It's like a whole tank of water, and then you have this little, maybe 1 millimeter radius hole, very small. But the area doesn't really matter for this, since area is not in the equation. You have to keep in mind that we need to apply what's in the equation. Sure, you could write P equals F over A, but it would make a lot more sense. And also, all we have up here, we are in a, we're going to assume that we are only dealing with atmospheric pressure. So what we would do, the most common way to deal with a problem like this is you take the pressure at this point, and you take the information. I like to say information for this because there's a lot of information. You need to know pressure, you need to know rho, you need to know velocity, rho, gravity, well, I mean rho and gravity are usually givens, and h. So how are we going to determine that? So first, you might notice some similarities to when you did conservation of energy. Conservation of energy looked pretty similar to this. And so now that we take a look at that, and if you remember, or one cool little thing, if you remember Pascal's principle, that that was actually derived from the equation for work. So you can kind of see the similarities with the conservation of energy, and essentially this is a offshoot of the conservation of energy. So that's one thing to keep in mind while doing this. So what's going to happen is we're going to take the information at this point, just for our purposes. You could take it at any other point, and this point right here. So let's say that this is point 1. So we're going to, let's say this is D1, why not? And then D2. So what can we find out? Let's do the information for D1 first. So what's the pressure there? Well, that's just going to be atmospheric pressure. So we can replace P1 with PATM. Okay. What's rho? It's going to be the density of water. Rho here, also that. Velocity. What's the velocity going to be? We don't know how fast this is going down. Well, usually, assuming that this is a really large tank and then that the hole that was made is really small, we can actually assume that in this case, it's going down at a very slow speed. That means that V is extremely close to 0. Usually, we just put it as 0. Usually, they'll either end up giving it to you, or you probably won't need to solve it unless all the other information is given, or you can just put it as 0. That's what I meant to say. I'm sorry. So this is basically 0 because this is such a large tank of water and you have such a small hole. And then we have rho GH. What's H going to be? Well, H is going to be, let's imagine that the bottom of this tank is ground level. I know it's not exactly straight, but that means we're imagining this is the height. Then what's P2 going to be? Well, at this point, the only pressure that's acting on it is also atmospheric pressure. So that's just going to be pressure atmospheric. So you can cancel out these terms. So pressure is virtually non-existent in this equation for now. In other cases, it will be needed. For velocity, that's what we're trying to find out. We don't know the velocity here, so that's our unknown. And also, one thing, once you take out the pressure, you can actually take out the rho's. So even if we don't know the density, you actually don't need to know the density for this problem. Now, we need to find out what H2 is. We know that this is approximately 0, so this whole term, I forgot to mention, is completely out. We kind of know H1, but not really. We need to know H2. So, if we do some little equation shifting, I'm going to move around things a little and see if you understand what is happening. So this is what I brought as, and this is supposed to be V2. So basically what I have here is I just move this term to up here. So we have GH1 minus GH2. You can factor out the G. You can't cancel it because it's not on the other side as well. But you can do H1 minus H2. And this is essentially the difference between the heights. So it's essentially all we need to know is this. So knowing that, we can use this to solve for the velocity. And you can do root of that as well. And this squared will be gone as well. So that is your velocity at which the water is coming out of this little hole. I hope this helped you understand Bernoulli's equation. If it did, please leave a like. Be sure to subscribe for more videos. Leave a suggestion as to what you'd like to see below. AP Physics 2 is a relatively undercovered topic, I'd say. So I tried to make videos on it because there aren't too many videos covering it. I'm sure, obviously, College Board released a lot of videos, but they are very long, and I hope to shorten it a bit for you. So I hope you enjoyed. Again, please subscribe. It would be really appreciated if you did. And thanks.